In this session, we shall start with the next concept, that is the equilibrium of concurrent and non-concurrent force system. So, to start with, what is equilibrium? So, a body is said to be in equilibrium when its static position or its motion with uniform velocity is not altered upon the acting of different forces. So, for that, if I consider a system of forces or a body, let us consider a body. So, this is the static position of this body. So, I am going to apply some of the forces on this body. So, upon applying these forces, if the position of this body is not altered, that means it does not move upon the acting of these forces, then this body is said to be in equilibrium. So, if I consider the bodies which are in motion, the body is moving with the uniform velocity, and on applying some of the forces on that body, if the uniform velocity of that body is not altered, then that body is also said to be in equilibrium. So, mostly this concept of equilibrium will be applied for the static bodies. So, a body is said to be in equilibrium when its static position means which is not moving, so which is at rest. When its static position or motion with uniform velocity is not altered when it is acted upon by the different forces. So, this is called as the equilibrium of a body. Next, we shall consider the equilibrium. So, what do you mean by this equilibrium? This equilibrium is a force or a moment required by an object to be in equilibrium. So, this equilibrium is a force or it may be a moment which is required by an object to be in equilibrium. So, this equilibrium is a force which is required by an object in order to keep that object in an equilibrium. So, there are two cases. One is for concurrent force system. So, for this concurrent force system, equilibrium is a force which is having a same magnitude as the resultant force, but in opposite direction. Why it is in opposite direction? But this needs to keep the object to be in equilibrium. So, for non-concurrent force system, this equilibrium is a force or a moment. If it is a force, this should have a same magnitude as resultant, again in opposite direction. If in this case the value of the resultant is 0, so this equilibrium may be a moment, again this should have same magnitude as resultant moment, again this should be in opposite sense of rotation. So, if the value of resultant is equal to 0, then the equilibrium will be a moment which is having the same magnitude as the resultant moment, but in opposite sense of rotation. So, next we shall consider the conditions of for static equilibrium of different force system. So, in that the first condition is conditions for equilibrium of coplanar concurrent force system. So, when I am explaining about the equilibrium, I told you that in case of concurrent force system, equilibrium is a force only. So, therefore, the resultant of the concurrent force system is a force which is acting through the point of concurrence of the given system of forces, and it must be equal to 0. That means which is nothing but a resultant force. In order to find out the resultant force, we need summation of Fx and summation of Fy. So, in order that the concurrent system to be in equilibrium, so these two cases should also be in equilibrium. That means summation of Fx should be equal to 0 and summation of Fy should be equal to 0. So, summation of Fx is equal to 0 is that the algebraic sum of all the x components of a force system is equal to 0, and summation of Fy is equal to 0, which means that the algebraic sum of all the y components or the vertical component of a force system is equal to 0. If both these components are equal to 0, then the given system of forces or the concurrent force system will be in equilibrium, because that object or the force system should not move, right. Next, in the second case, we shall consider the conditions for the equilibrium of coplanar non-concurrent force system. So, again for non-concurrent force system, I told you that a equilibrium may be a force or a moment. So, this will going to constitute the conditions that for force, that is summation of Fx is equal to 0 and summation of Fy is equal to 0, or if in case if the resultant force is 0, this will going to constitute for the moment as a resultant. So, that means summation of the moment should be equal to 0. So, this means that the algebraic sum of all the x component of a force system is equal to 0, and the algebraic sum of all the y components of a force system is equal to 0. So, summation of moment, the algebraic sum of moment of all the forces is equal to 0. Then we should use these three conditions for the equilibrium of coplanar non-concurrent force system and should be equal to 0 about any point. So, these are the conditions of static equilibrium for different force system. Next, we shall consider the Lami's theorem. So, we shall take up the first concept, that is Lami's theorem. So, what does this Lami's theorem says that if three coplanar concurrent forces are in equilibrium, then each force is directly proportional to or equal to the sine of angle between the other two forces. So, it states that if three coplanar concurrent forces are in equilibrium, then each force is directly proportional to the sine of angle between the other two forces. So, to prove this, let us consider the three coplanar concurrent forces in equilibrium. Let us consider F1, F2 and F3 as three concurrent forces. So, the angle between F2 and F3 is alpha, the angle between F3 and F1 is beta, and the angle between F1 and F2 as gamma. So, when these three forces are coplanar concurrent force system, so these three forces can be represented by the sides of a triangle both in magnitude and direction, and this is based on the law of converse of a triangle. This is based on law of converse of the triangle. So, what does this says is that when three forces and when three concurrent forces are in equilibrium and it is coplanar, these three forces can be represented by the sides of a triangle both in magnitude and direction. So, let us write the figure. So, this is F1, you should write it in a same direction. So, this is the direction of F2 and this is the direction of F3. The angle between F1 and F2 is gamma, the angle between F2 and F3 is alpha, and the angle between F3 and F1 is beta. So, the interior angles become, the total angle is 180 degree. So this becomes 180 minus gamma, and this becomes 180 minus alpha, and this becomes 180 minus beta. So now we shall apply the sine rule. What does this sine rule says? That if the three forces are represented in sides of a triangle, then each force is directly proportional to, or each side is directly proportional to, the sine of angle between the other two forces. So we shall apply the sine rule for this figure 2. So on applying sine rule for this figure 2, so first we shall consider the magnitude of the first force, that is F1. This F1 is directly proportional to the sine of angle between the other two. What is the angle between the other two forces now? This is F1. We need to consider the angle between other two forces, that is F2 and F3. So therefore the angle between these two forces is 180 minus alpha. Similarly, consider the second force, that is F2, which is directly proportional to the angle, sine of angle between the other two. So what is the angle between other two forces? Now I am considering F2 force. I need to consider the angle between F1 and F3, that is 180 minus beta. And this is equal to, next force is F3, and if I consider the force F3, I need to consider the angle between other two forces, that is F1 and F2, that is 180 minus gamma. So this is equal to some constant. This is equal to some constant. So what is sine of 180 minus alpha? It is sine alpha, which is equal to F2 divided by sine of 180 minus beta is sine beta, and F3 divided by sine gamma, which is equal to some constant. So now this can be written as F1 is equal to some constant multiplied by sine alpha, or F1 is directly proportional to sine alpha. Similarly, F2 is directly proportional to sine beta, and F3 is directly proportional to sine gamma. So hence proved. So which means to say that each force, if three coplanar concurrent forces are in equilibrium, so we have considered F1, F2, F3 as the three forces which are coplanar and concurrent, and each force is directly proportional to the sine of angle between the other two forces. The sine of angle between the other two forces. See, observe here in the figure 1, if I consider F1, this is equal to the angle between other two forces, that is alpha, and F2 is directly proportional to the sine of angle between other two forces, that is beta, and F3 is directly proportional to the sine of angle between other two forces, that is sine gamma. So hence Lami's theorem is proved. So let us discuss about the next topic, that is free body diagram. So what do you mean by this free body diagram? So free body diagram of a body or a part of a body is the diagram which shows all the forces which are acting on the body, keeping that body in equilibrium, including the support reaction at the restraint point and the self weight of the body. So, what is free body diagram? So, free body diagram, this can be written as FBD, free body diagram of a body or a part of a body is the diagram which shows all the forces acting on the body, keeping that body in equilibrium, which includes the support reaction at restraint points and also the self weight of the body. So, in order to explain this free body diagram, let us take up one example. Let us consider a sphere which is having the self weight of W and supported by a smooth surface at point A. So, if this sphere is not supported by this surface, this sphere would have been sink into the surface. That means the motion of this sphere is restricted by this surface at point A. That is, this sphere is applying some action towards this surface. For the action developed, this point on the surface is developing the same reaction towards this sphere. So, this point is called as restraint point and the reaction developed towards the sphere is called as support reaction, or it is also called as normal force or the reaction force. So, the free body diagram of this sphere can be written as, so the self weight of the body will going to act in vertically downward direction, that is W. This point is restricting the motion of the sphere at point A, hence the surface is developing some reaction towards this sphere. Hence, at point A, there is a support reaction developed which can be represented as R, that is reaction at point A. Let us consider again the second example. So let us consider a trough inside of which there are two spheres. So let us consider this as sphere A and this as sphere B. So the self weight of this sphere is W1 and this sphere is W2, and it has 1, 2, 3 restraint points, and also there is an intermediate restraint point between these two spheres. So totally there are 4 restraint points. So at A, B and D, this trough is restricting the motion of these two spheres. At point C, the motion of the sphere A is restricted or restrained by this sphere B. Similarly, the motion of this sphere B is restricted or restrained by this sphere A. So let us consider the free body diagram of these two spheres separately. So let us consider the sphere A. The self weight of the sphere is W1, which will going to act in vertically downward direction, and this sphere has 3 restraint points A, B and C. So the reaction developed by the trough towards this sphere at point A is horizontal and this is RA, and at point B the reaction developed by the trough towards the sphere is RB, and at point C the orientation of the sphere is inclined. So therefore the reaction developed by this sphere B towards sphere A is also inclined, and all these reaction or the forces will going to pass through the point of concurrence. So this again can be written as, this is the point of concurrence. Let us consider this as point O. One is the self weight which is acting in vertically downward direction. Next one at reaction at A which is acting towards the right. So that is RA. And at point B the reaction is vertically upwards, that is RB, but at point C the reaction developed is inclined and the direction of which will going to lie in the third quadrant. Next, let us consider the sphere B. The weight of which is W2, which will going to act in vertically downward direction. Next, at point D, the reaction developed by the trough towards the sphere is RD and it is horizontal. Again at point C, the motion of this sphere B is restricted by sphere A and the reaction developed is towards sphere B at point C. So that is RC. So this again can be written through the point of concurrence. All these forces should pass through the point of concurrence only. So the self weight will going to act in vertically downward direction. Next at point D the reaction is towards left, and at point C the reaction developed is inclined, so that is RC. Next, let us consider again a sphere with tensile wire or the tension wire. So let us consider a sphere which is supported by a smooth surface and a tensile wire. So the self weight of which is W. So if I write the free body diagram of this sphere, first the self weight will going to act through the centroid point and it will going to act in vertically downward direction, that is W, and this smooth surface is supporting or restricting the motion of this sphere, that is it will going to develop a reaction force at A, that is RA, and there is a tension wire or a cable which will going to develop a tensile force. We know that the tensile force will always going to act in outward direction from the point or away from the point. So that is, it develops a tensile force T. So we can write all these reactions through the point of concurrence, that is, this is W, this is the tensile force, and the reaction RA is acting towards the right. So this is the general free body diagram of this sphere. Next, let us consider the free body diagram of a ladder, which so why it needs to be represented through the point of concurrence is that we need to keep that body in equilibrium, right? So let us consider a ladder and let us consider this as point A, B and C. So there is a man of weight 600 Newton is standing on the ladder. There is a horizontal force, external force P, which is acting horizontally at point A. So now let us consider the ladder. So at point A, the sliding action of the ladder is restricted by this point, or the reaction is developed by this surface towards the ladder. So which is vertically upwards, and this can be written as RA. And there is a external force P which is acting at point A and it is horizontal. Next, again at this point, let us consider this as point D. So at D there is a man standing who is having a weight 600 Newton. So this P, 600 Newton are all called as the external forces. So at point C there is again here the sliding of this ladder is restricted by the wall at point C. That means the reaction developed is towards the ladder from the wall. This can be written as RC. And another one is the self weight of the ladder. The self weight of the ladder which will going to act through the centroid point of the ladder. So that is W. So this is the free body diagram of the ladder. So now let us consider some important points before solving the problems on this equilibrium conditions. So, in that first one is, if a member is subjected to a pull may be called as a tension force. Tension force, here the reaction R will act away from the end, then we can say that they are in tension. So, this can be written as, if I consider a member AB and if it is subjected to a pull, that means if it is subjected to this kind of action, so the reaction developed will be away from this point, and this is away from this point. Next, second one, if the forces in the member or when it is subjected to a push, that is compression, or towards the if the forces in the member are towards the end, then they are in compression. So, this can be shown as below. Let us again consider a member AB. If it is subjected to a push, then the reaction developed will be towards the point. So, that means it is acting towards the point. It is acting towards the end or towards the point. Then this can be said that this member is in compression. Next, let us consider the third important point. The strings ropes, cables, wires, chains are always subjected to the tensile force only. So, as I explained in the free body diagram, if you consider a wire or a cable which is held by the spear, so that cable will always going to be subjected to the tensile force only, which will going to act away from the end. Next important point is, if a string carrying freely hanging load on one side, this will be in tension if such string passes round a frictionless pulley frictionless pulley, then there will be a tension on either side, that means on both the sides of pulley remains same as shown in the below figure. So, if I consider a pulley and a freely hanging load, let us consider this load as W on one side, then this will be in tension, and if this string is hanging around a frictionless pulley or passes through a frictionless pulley, then on both the sides there will be a tension and this remains the same as this weight. So that is, this will going to develop. So from this point the tensile force will always going to act in outward direction. Again from this point this tensile force will going to act in outward direction. So this is the string and this is called as a frictionless pulley. So hence here the tensile force will be is equal to the freely hanging load. Next, reactions are directed towards the centroid of the body in order to maintain the equilibrium. Next point is self weight of any body will always going to act in vertically downward direction towards the centroid of the body. So these are all the important things we should keep in mind before solving any of the problems on equilibrium of forces.